So first things first, my name is Wilfred Githuka Gachugi. On the paper there, I think there's a mistake, but I don't think that's not a big deal. I'm from an engineering background, electrical electronics, and I got into programming. My first language was Pascal. Then I also did some C++ back in school. Then last year, something interesting happened. Driving down Thika Road, I was in a matatu just like any other Kenyan, going to work, going to school, going to work. And the driver was saying something very interesting that really opened my mind. He was saying, Igari, I was speaking Kiswahili, Igari inajua nyumbani. Hata nikiachilia, hiyo steering wheel itajipeleka tu. Well, that may seem funny, and that really got me into thinking about self-driving cars and autonomous vehicles. I did my research, and I realized it's still something very new. It's not, some people might say it's not ethical, it's a bit complex. It will make people lose jobs, it will revolutionize transportation, to do everything. And I decided I want to do that for the rest of my life. I'll be the first person who's going to bring the first fully autonomous vehicle in Kenya. That's quite a big mile on my hand. But today I'm just gonna give you stuff I've been doing into self-driving cars and autonomous vehicles. If you realize if you Google everything about self-driving cars and autonomous vehicles, lane detection systems, smart driving systems, all of them are closely encompassed in US, mostly in California. I think California is one of the few states that has allowed public testing of these vehicles. But I decided, what about Africa? Once I shared with my friends about this concept, what happened if you had an autonomous vehicle in Kenya, an autonomous vehicle in Africa, or in self-driving cars? Everybody will say, no, that can't happen because our roads are not ready for robotics. Our roads are pathetic. People drive in a very bad way. People don't like roads anymore. But that really got me into thinking, even us, we can do it. If they can do it, us, we can do it. And that's what made me go deeper into this. Last year, around the same time, I also started teaching myself Python, learnpythonthehardway.org. That website was amazing. And that made me go deeper into self-driving cars. So today, I'm just gonna give you a demonstration of what I've been working on. Real-time lane detection systems are algorithm for self-driving autonomous vehicle. Basically, what this means is how a car sees the road. How a human versus how a human person sees it. When you're driving a car, you're probably focusing on the front part, or maybe something crosses over your side view, you probably look, and again, 2 seconds you're back on the road. But how does a car see the road? How does a car know that when I reach at a junction, I must stop? Or when the yellow lines at the center of the road or at the side of the road mean this and this? Probably many of us don't even know what those color codes mean, but we just drive. So now, first things first, I want you to make this very clear. These two terms are not the same. They actually mean very different things. Self-driving cars versus autonomous vehicle. So a self-driving car is basically as simple as it is a car which can drive itself. And what this basically means is you go into a car and it takes you to your destination from point A to B. You don't do anything. It's like a lift. But a lift, probably you have to press a button. Now in a car, a self-driving car, which is the future, 10, 20, 10, 30 years from now, you get in and it offers you mobility. You go in and it takes you. This second point here perceives the environment and moves where safe and desirable. New human supervision required. But the main thing is this last point here, which I think should have been put on the first point. Change of infrastructure. You cannot introduce a full self-driving car without modifying the infrastructure. That's the cost that comes with it, because that car we rely on the information that is available on its surrounding to be able to make a decision. And this is not yet available. We are very, very many years from this type of a car. What we have right now is an autonomous vehicle. Autonomy is a word which means on my own. I can do this on my own. What does this mean? Is with an autonomous vehicle, you still own the car. It's most favored by manufacturers. Probably if you own a car right now and you don't know, you probably own a semi-autonomous vehicle. It has some form of autonomy, basically mean that when you're driving the car, for those guys who have probably a modern vehicle, it has cruise control. You can let go of the accelerator and the car will automatically accelerate itself, but probably it doesn't have lane detection systems, it doesn't have maybe crash collision, it doesn't have lane, there's a one that makes sure it keeps on the lane. Well, maybe 2017 or 2018 models probably will have more than 50% autonomy. But at the moment, we have 6 types of levels of autonomy. And if you look at this, I don't know if the guys at the behind can see this. We are currently level 2 and level 3. So let me go quickly what this means. Level 0 is, there's no autonomy in a level 0 car. This is basically 1980s vehicles, 1970s. Let me not go so much, but somewhere there. Level 1 is cars that can handle one task at a time, like automatic braking. Some cars have a feature where when you go close to the bumper, you hear something like that. Some cars have this type of. Level 2, these cars will have at least 2 automated functions. Same thing, crash collision. It also has a system that can make sure that if you let go of the steering wheel or you start sleeping on the steering wheel, the car will probably give you a feedback and make you come back. Level 3 has been promised. These cars can have dynamic braking, but might still need intervention. This is where we are. And all the news we've been hearing about autonomous vehicles, we are still at level 3. Level 4 and level 5, this is expect 2026 onwards. This one, I can maybe say 2030. One of the hindrances for these technologies to move ahead is the legal part of it. Very few countries are willing companies to come and set up such vehicles because the direct impact of it will be in any transportation system, be it a delivery system or just a taxi cab system. The most expensive part is the driver. If you remove the driver from that chain, everything that you buy right now becomes very cheap. Because if I'm supposed to deliver a product to you, I have to cost in the cost of paying the driver. And if we have level 5 or level 4, even level 3 on some countries, it's still very hard to take it up. And so now let me just go straight to how a vehicle sees the road. This is level 3, level 2. Vehicles don't normally see the road just like the way we are. They don't have perceptive vision whereby you look at one thing. Say for example, any of you is driving at the moment and you can only focus on one thing at the same time. What this means that you can only focus on the street light but cannot focus on something else. You can see it in your vision but you cannot focus on it. And until you point your eyes to it, that's when you can actually start reacting to it. A car sees differently. If you have seen any tests by Waymo, which other companies are doing this thing, even Tesla's, no, but Tesla don't use this. But any other companies, they normally have an object on the vehicle itself. That object is called a LiDAR. And it's normally has, inside it is a camera that rotates 360 and projects a laser, which if it hits on this whole room, it can produce a laser vision of this whole room at probably every second that car moves. So it has feedback on everything that is happening around it. when you're driving, this is how probably you see. Let me see that. Yeah, this is what we see as humans when you're driving. But a car, this is what it sees. Everything around the vehicle is within, I can say the car knows it's there. But us, we can only see and focus. If this lady is driving, she's probably focusing on this point here or on this car that is moving around. But in case like what is available on the Model S of a Tesla, when you're driving the car, it's already doing the math between these two vehicles. But when you're driving the car, you're probably assuming that maybe this car and this car, probably the drivers know what they're doing, but when an accident happens, many people don't even know what happened. So what I've been doing, let me go back to that slide. So why should I use Python? Why Python when I'm trying to develop self-driving cars? Well, I could use languages like C. Or because libraries like TensorFlow that we normally work with on Python. I also have versatility and fewer programming codes. And I think most people know, all of you use Python know this. All right, enough of the US stuff. Let's come back home. I think this makes more sense now. All these companies here, this is the Kenya Urban Roads Authority, Kenya National Highways Authority, the County Council, the National Transport and Safety Authority, and the Ministry of Transport are the companies or the entities that are involved if you wanted to set up your own self-driving car here. I'm hoping that, and this is going to record that maybe by 2017, in the next 4 years, after I go into strict development, I can be able to put my first autonomous vehicle, maybe at level 3 on the road. These are the guys I would have to talk to. And I don't know how they will respond, but I'm sure they'll probably think I'm crazy. This is the current situation of the roads in Kenya. It's a mess. It's a mess, not because we are bad drivers, but whenever we are driving, all of us have emotions into it. No one here drives when they're normally calm. If somebody calls you a name when you're driving, you probably throw another response, another insult back at them. And this is what we result. So, data collection. This is what I've been doing of late. I'm sorry this picture is not clear, but what is here is the dashboard of a car. And this is my phone, the one I normally mount on the dashboard to take video data when the car is driving. Why do I do this? I do this because I want to see how a normal driver drives on the road. In my own research, I've categorized drivers according to how they drive on the road. I consider a matatu driver somebody who's on the higher scale because they normally drive quite fast and their response is very fast, as according to a new driver who's normally pretty much very low. Somebody who drives very carefully, holds the steering firm, and is just any small hoot, they freak out. That is, I consider that person at maybe lower level. A mid-level, I'll consider somebody who's been driving for the past 5 years is comfortable, and that's the kind of data I'm getting here. So in my data collection tools, I use a homemade phone mount rig. This is, I used, what is this thing called? Selfie sticks. Yeah, a selfie stick has a phone gripper at the top. So I took that apart and made a base for it that could hold the phone well on the dashboard. Sometimes you need to use some tape to hold it down carefully. FFmpeg, I think most guys are familiar with it. It's a robust video and tool. ImageMagick, the same class. It's an image processing software which are normally used to extract images from the video. And Python OpenCV. Finally, time, patience, and humility. Pip's gonna ask you what you're doing. I get this very much time, but what are you collecting this video data for? What are you doing? I once was collecting data from a matatu driver, a matatu vehicle. We're heading to town. Of course, after talking with the driver, he agreed, but he was very shocked. Like, he asked me in Kiswahili, sasa hii ni nini? Hii video. Talk to the driver or the person who's going to be driving. Get them to know, to understand, whatever you put on the dashboard should not at any one time distract the driver, because that brings in some very complexities of safety. So, I don't know if this video can play here. This is a sample video of, I don't think it's clear, yeah. This is a video of a normal person driving the road. It's not visible here, I'm so sorry. But I'm gonna take you down to 7 steps of lane detection. This is how I normally classify my images and get to see how a computer will be able to detect the lanes on the road. So the first thing is, let me just list them. The first thing is first to convert the image to, thank you, the image from RGB to grayscale. What this means is a normal color image, you throw it into a grayscale, that's the black and white and gray. The second thing, I apply a Gaussian smoothing to make the image fine. The third thing is a Canny edge detector transformation. The fourth is a get the region of interest, the point at where I want my software to focus on. Finally here is merge the original, apply the hue transform. A hue transform is a mathematical function that draws lines. If you remember your high school math, y is equals to mx plus c, from any curve it can draw a straight line. And lastly is I merge the original image with the lines. That is, from what I get from the hue transform, I place it on the original image. And finally, live video testing. So let's do this. So this is the first image. This image is in grayscale. So what I've done is I've just taken the original image, run this OpenCV function here below that takes in an image and converts into grayscale. The second is applying a Gaussian smoothing. One of the reasons why you apply a Gaussian smoothing is because to make the image fine. When you take an image using a normal photograph, and you draw like this one's board photography, there's normally a histogram. The image is normally not very smooth. It has a lot of color levels, which are normally not very friendly when you want to apply a Canny edge detection on it. So you have to first smooth it, then apply this. So what is a Canny edge detector or a Canny edge transformation? This is not clear, but what you're supposed to see, if this was clear, is you see from this image here. Can you guys be able to see the white line here? This is a normal lane marking of the road. When you apply a Canny edge detector, what it does is it compares the color difference between the white line and the color around it, which normally a bit black because the road is black. And what it gets is the edge. So it allows me to remove all the other nonsense from the picture and leave me only with the edges of the most important things in this image. When you get this PowerPoint, I'll put it up on my GitHub, you'll be able to see clearly. So this is just an explanation of what a Canny edge detector does. It uses, a Canny edge detector is an edge detection operator that uses a multi-stage algorithm to detect a wide range of images, invented by or created by Johnny Canny himself, who recommended a threshold of 1:2. This threshold, what it means is when you use a threshold of 1:2, you're just trying to compare between the line which you want and the negative side of it. When you use a higher threshold, it increases the sensitivity. That means it's gonna see more things or see less things. But since here all we want to see is the lanes on the road, because that's the most important thing. Every other thing is not important for now. The lanes on the road. So I need to make sure that the road surface, which is a common color of navy blue heading to dark, should be removed, and all I should see is the edge of the road, which is the yellow line. Because on a surface, the yellow or the white is the most striking thing that a car will see. All right, next is the region of interest. This is what normally happens when you're not focusing on the road. So for our car, we don't want a car to focus on the birds in the air. Yes, it can do that. A K&E edge detector will get a bird which has been caught by the photo in the air. But I need to focus the region of interest just on the horizon and the road coming outwards to tilt to the bumper. So when I apply the region of interest, like in this image, which I'm sorry you can't see, but what I will get, I will draw a, how do you call this? I think an obtuse triangle or something like that. It will remove all this information from the image, and what I will get is I will have this whole area only visible from here downwards. This is the area that has the road that is going into the horizon. And finally, the hue transform. What I just mentioned right now is the hue is a mathematical function, and I'm so sorry. These two images contain the output of this hue transform. It's basically two lines on each image which are trying to trace where the K&E edge detector left the lanes. So what do I mean? I'm only having two lines from here to here which have a common intersection at around a point here, which is the same for this. But yes?
Can we turn off the light? I think the slides are more important than...
All right, yeah.
Like we can't see. It's too black rectangle.
Okay. So as he does that, what I'm just saying is the hue transform is a game changer in all this. Without this, there's no way. It's very hard to express because an image normally has a lot of properties. And through Python, when you use the hue transform, you're just trying to do simple math. Like I have a curve. Because when you're driving, the road will normally do like this in the horizon. At one point, it will turn to the left.
Excuse me, sorry to interrupt.
Okay.
Your time is still 5:30, and tea is being served right now, so you can just wait.
All right. Okay. All right. So what I'm just trying to say here is when you're driving, the road keeps moving like this. But a car needs to know where exactly is the road going to. So what it will use the mathematical function of y is equals to mx plus c and draw a straight line before the road actually makes a turn. So it's like it's trying to guide you where the road will move next. Your eyes will see a road laid like this, but a car will see something of that sort. And finally, I merge the RGB image, which is this, with the output of the hue transform, and I think it's almost visible on that side. But here, when you see this presentation on GitHub, you'll see red lines moving like this, and also on this point, like this and like this. That's exactly what the car will see. So what are the problems I encountered when I'm doing this? One thing is poor video quality. If the video quality is not clear, my algo will not be able to detect the lanes on the road. And of course, most of our roads don't have lanes or have uneven markings. Also, I've noticed the vibration on the bumper because of the movement of the vehicle. I've also tried to add a compensator on my mounting rig to make sure that I can at least cancel out all those vibrations to be able to do this. The solutions: apply an advanced lane detection algo. I'm working on a new detection, which I'm hoping by end of mid-October, I'll be able to test it out on using a more advanced system to be able to detect the lanes on the road. The camera video device needs to be mounted on the bumper to get this. Yeah, this is one thing that I've been having a problem because I've been mounting my camera or my video input device on the dashboard, meaning that the refractory index of the windscreen affects the video quality. So I'm working on a new device which I'll be able to mount on just there on the bumper on a place it can be affected by maybe objects in the air to be able to get a clear vision of the road. Finally, when I'm closing, if you want to do this, remember safety. This is new technology, and just as new technology needs to be tested to be verified that it's going to work well. Be safe and keep your eyes on the road as you do your research. Thank you so much. Any questions? Yes.
It's important to your work that you collect data from different environments, such as when it's at night, or when it's raining, or when it's cold or hot.
Yes. Different weather conditions are important. I've also been working on videos at night. That has worked well, though I couldn't bring it. If I brought it here, I'm sure you guys wouldn't be able to see it. But at night, it even works better, but the problem is the glare from the oncoming vehicles, which distorts the, because if the glare appears to be brighter than the lane markings, or it produces a color that is a variant of yellow and white, that confuses my algo, so that has been a problem. But definitely that is important. Yes.
So for the vibration problem that you mentioned, have you considered for pre-processing your video with like a low-pass filter or just smoothing, time smoothing?
Definitely. In fact, mostly I was using FFmpeg to post-process the video, but I realized that there's Adobe Premiere Pro which also managed to remove vibrations on a larger scale than FFmpeg. But yeah, I'm sure definitely that has been looked into. Another question?
Yeah, so I see you have like started to build it from the scratch.
Yeah.
And isn't there some like open source thing where people contribute and you can get some of the things already done?
Not that I know of, but when it comes to lane detection, it's pretty much, there's so much you can do, because you only rely on so much on the data that you get. In terms of hardware, I think it's any hardware that has a video capture device, even your webcam, you can pretty much do that on that. Unless I build one community, or you help me build a community, then I think that would be great. Yes?
Okay, from his question,
yes.
I was looking at a project called Comma.ai.
Yes, I know Comma.ai.
Yeah, so is that one of the projects you can adapt to actually build some driving cars?
Yes, I like what Comma.ai does, because their device basically connects to the port, it's called OBD port on your vehicle down there. That is good, but the challenge of that is I'd have a specific test vehicle to do that, because it has its own legal implications. Yes. So, yes? No problem.
But I'm just trying to think, there's a slide you said, coming back home.
Yeah.
Just, it hit me that you probably have a higher percentage of things that don't have lanes. So, for the sake of your project, you just work with the test data was just limited to roads that are lane?
Yes, for this specific project, it was limited to specifically roads that have the boundary markings, the lanes. But definitely, since most of our roads don't have that, I've started to think outside the box. Maybe I can do that with the help of get myself a LiDAR device or GPS or something like that, because I'm very limited to lanes on the roads. Yeah. Yes.
So what are the parameters that you're considering when you are trying to do that kind of simulation?
The main parameters are basically the way the driver does. Then I get somebody who's really good, like a Matatu driver, who drives much faster and much more complex. So what I'm trying to do is I'm trying to get, like, using those are the bounds of my equation. So I'm trying to get like the middle ground. So if I'm testing my algo, it needs to know that this is how a normal driver is supposed to drive, because it has the maximum and the minimum.
I'm asking that because in a real traffic scenario, you find that you have different sizes of vehicles.
Yes.
Like, for example, is the same consideration that you're doing for a trailer the same you're doing for a saloon car?
No, they cannot be the same, because the challenge of long vehicles like a trailer or a bus is when the car or like the system knows that it's driving within the lane markings, that's correct, but the rear part of the vehicle is probably out already. So I've not tested out on large vehicles. I'm more focusing on the small, more used vehicles like the saloon vehicles. Yeah. Any question? Just to add on something small, to scale this, I've been doing something that, because I need a lot of data to do this. We are working on a project whereby you can, it's still in the works, but I thought it's good to share, where you have your own vehicle and you could put a device which can record your driving patterns. Your work is just be able to, it will probably be aftermarket. So it's mounted on the vehicle, it records the person driving the vehicle over an X period of time. Then we get the data and we pay you for that service. It's still a works in the art, it's still a project in the works, but I thought it could be able to inspire anyone who's doing the same thing. So I think in the interest of time, I'll stop there. And thank you so much, guys, for listening.